Okay, how do we sketch a COT graph? Ooh, fun and games. So what we're going to do is a number of steps. First off, let's find the period. So here we have pi on b is the period, so pi divide the b number, which is a pi divide 6, and that gives your whole number 6. Now you have to then look for a half period. Now a half period is important for COT only, because if you think about the COT graph, here we have it. Okay, see you've got 2 cycles of a COT graph there, and that's 2 cycles of a negative COT graph. And what we have is, in those 2 cycles from there to there, well, we've actually drawn from 0 to 2 pi of our 2 cycles. So one cycle is in pi units. So that's why we've got a period of pi divide b instead of 2 pi divide b. So a half period is important because there's just 2 main features, the middle point and then the asymptote, and the middle point and then the asymptote. Because there's only 2 main features, we need to be able to divide the thing in halves. So a half period is important. So you can use the half period to find a middle point, and then after that an asymptote. Or you can recognize that the spacing between any 2 asymptotes, the first asymptote and the next asymptote, that's one whole period. So in this case, for our COT, the spacing between 2 asymptotes is a 6. So once we've got the period and we've worked out our half period and we've got an understanding of asymptotes and middle points and how far apart they are, we've got to identify what's the size of the shift that's going to happen here. So first off, you take the stuff inside the brackets, there it is, and then you've got to factorize out the number in front of the x, the pi on 6. And we do that because we want to end up with some number here that is plussing or minusing just the x per numeral only. Nothing times the x, just the x by itself. And that tells you now how many units we're shifting the x coordinate. Okay, so an x plus 2, it means we're shifting 2 units in the negative. That's supposed to be a negative. In the negative x direction. Negative x direction. So we're going left. We're going left this way. Okay, so keeping that in mind, now let's locate the shift. Okay, and we're going to try and find that where is the first asymptote. So usually on a graph like the negative COT graph, looking for the first asymptote, which usually without a shift, that just sits on a y-axis. Right here, the first asymptote. But when we shift it, we're shifting it 2 units here in the left direction. So let's see where that can be thought about. So there's the y-axis. Now we're shifting it this direction to the left, so it's out of the screen. There's in towards the negative, and that's off the graph. So we can't draw the location of that first asymptote. So what do? Well, let's think about the same thing but using the second asymptote. Second asymptote, which is one whole period away. Okay, so one whole period is 6 units away. So starting from the y-axis, let's move across 6 units. 1, 2, 3, 4, 5, 6. Okay, so there's 6 units away. Along the 6, that would be the second asymptote. But we're shifting that second asymptote 2 units in the positive x direction to the left. 1, 2 on the 4. Okay, there it is. X equals 4. So that now is the spot of an asymptote we found. So from there we can get this point. This is a middle point of the graph. Now a middle point is a half period of 3 units away. So from an asymptote we can get a middle by starting an asymptote and counting 1, 2, 3. A half period moving in any direction. I've got I can get a middle point to the left of an asymptote, and I can get a middle point to the right of an asymptote. But on this side, I've only got 1, 2 spaces, and then there's no more, and I'm off my graph. So that's why I went over to the left to find a middle point. So I've got those main features put on the graph so far. Okay. Now the next important thing are endpoints, because here I'm sketching across a domain from 0 to 2 pi. So I need to find my endpoints. So I evaluate my function at the first endpoint, x equals 0. Okay, 0 times pi on 6 plus pi on 3, well, that will just give you a negative cot of pi on 3, which is 1 over tan of pi on 3. And 1 over tan of pi on 3, well, that's going to give you 1 over pi on 3, which is a negative root 3 on 3. Okay, which is approximately about a negative 0.6. So let's find that point. There it is, about there. So when x is 0, I've got a y value of negative 0.6, and I need to show my endpoint coordinate. Let's do the same at the other end, when x is 2 pi. And you would find that if I evaluate negative cot with x equals 2 pi, I'm going to get the exact same value. So that's over on this side. There it is, that's the endpoint there. When x equals 2 pi, I've got y equals about negative 0.6. So I put those 2 points in and I label the coordinates. That's very important. Okay, now that's all we need to do really at the end, is just follow the shape of our cot graph. Okay, it comes up from the negative cot graph, it comes up from the asymptote and goes towards the middle. And then on the other side, coming down from the asymptote and goes towards the middle, and then towards the endpoint. And there we have it.